Welcome to the summary of time patterns in big history, cycles, fractals, waves, transitions, and singularities. I'm David Lepore, and this book was published in 2020. So part of a guide to this is that we look at patterns in time that offer clues to dynamics. And such patterns include fractals, transitions, scaling laws, which suggest complex adaptive systems. And we have the longer that we can look back, the further we can look in the future. By Winston Churchill, who said, the more you study history, the further back you go, the longer the pattern you can create, the more further in the future you can plan and create scenarios for. So the plan that we're going to take a look at this book is kind of start nearby and then work ourselves back through history and then kind of look forward a little bit. So the first thing is we're going to look at the individual fractal pattern from 1 day to about 70 years. So we have some timeline. Then we're going to stretch that a little bit, look at technology waves of 70 to 100 years for many cycles in the modern era. And then we'll look at national dynamics a little bit further, 375 years for many cycles. Civilization stages, 50 to 5,000 years. And then we'll make that more generalized and look at integrated evolution. And the further back we look, the better we can understand what's going on now with a potential singularity where things are speeding up. So then we'll look at a pattern extension with a cone. So we know what happened in the past and what would happen potentially if that pattern continued in a certain way. And now we'll look at what's happening now. Very interesting point is at the inflection where there's a lot of nonlinearities and a lot of need for collaboration. So first we'll look at individual fractal pattern. And what I have on the side is kind of interlocking gears. So each one of these gears is interlocked. There's 6 gears around it. So one turns, the other one turns, and it's a fractal pattern. Keeps on going, smaller and smaller gears in there. And just to remind us of kind of what we experience in various cycles, particularly rest. So we consider human rest. We could look at the frequency and the fraction. So obviously during a day, we have about 8 hours of sleep in a 24-hour day. So that's about a 33% rest cycle. During a week, 7 days, 1 day of rest per 7 days of official and personal work. Might consider that 2 days of rest, Saturday and Sunday. 1 day would be 15%, 2 would be closer to 30. Then we look at, call a super month, a little bit between a season and a month, and that's 7 weeks. It's kind of on the order of kind of a holiday. So about 7 of these within a year, so about 7 different holidays. That's kind of the federal average. So that's about a 10% rest. Then a year, we have about a 3 weeks vacation, so that's 6% of that time frame. So you see we went from day to week to 7 weeks to a year. Each one of these went up by a factor of 7. That is, there's 7 days in a week, 7 weeks in this super month, and 7 of these periods in a year. That give us 49 weeks, about a year. So then we continue on. What would happen is 7 times that, so 7 years. Be midlife change, a structural unemployment rate between jobs, for example. And depending on how long that lasts, that's like 5% of the time. Then we have 7 times that, be a life or generation, or 50 years, and where we'd have some type of retirement. Current retirements average around 20 years. But that has been growing quite a bit. So right now it's 25%, but in the near past it was more like 6%. And then finally we stretch it just one more time to a system test at 350 years. And so we look at what kind of rest might be in there, which and this is not necessarily a rest at all. but long periods of war in the First and Second World War, the 30 Years' War, and that would be 10% of that time period. And we'll come back to look at the system test over 350 years. The idea is that there is something to test within a civilization, and that some dynasty or a nation kind of lives on 350 years before it begins to reorganize. So we'll take a look at that a little bit later. So now we'll extend it a little bit to technology waves, and there are various waves of cognitive energy, physics, and capitalism. So one of them is the waves of substitution of energies from wood to coal to oil and natural gas, and then to nuclear and renewables. So this is hydro and nuclear power. And what's really kind of been taken over is kind of efficiency. So these are kind of waves first shown by Marchetti in the 70s. He had predicted that this nuclear would take off at that time. Just as he was kind of predicting it, nuclear kind of stalled. And in fact, the price shocks, oil price shocks of the 1970s led to higher efficiency. So we're actually putting capital into making things more energy efficient. And so here we look at the amount of energy kind of that we did not have to use because we have more efficient machines. If we look at physics, the history of physics from the early part of Newton and Galileo to the more recent period with string physics or membrane or whatever it's currently being called. And we see that first it started out kind of slow. There were 3 topics kind of discussed and worked on. And then kind of in the early 1800s, there was thermodynamics and electrodynamics, giving a lot of useful technologies. Then it sped up again on the late 1890s into the 20th century with atomic physics and special relativity, and then it sped up tremendously in the 1920s and 30s with general relativity, quantum mechanics, and nuclear, kind of rewriting a lot of the basics of physics. And then it kind of slowed down with high energy physics and the large accelerators, and it takes a lot longer to make discoveries, but definitely things are out there to yet discover. And so this will continue on. So as time progressed, the time between these major discoveries decreased and is increasing again. So we can look at, we plot the width on this particular scale. Then finally in energy, also besides substitution, there's a factor of energy. If you look at leadership of capitalism, it was in the Netherlands, a lot of peat, some wood and wind. England had a lot more forests, also had some coal, then moved on to the UK with more coal usage, and then finally to the US with oil. And it pretty much the population would double and the energy would go up by a larger factor over these time periods. Within these, besides technology, there are also dynamics within the country. And so I took a look at the US, and here we take a look at 3 separate patterns. And that is, the first one at the top is the US kind of in being part of world leadership. From 1945 to the current time. What we have is kind of 8 years of one party followed by 8 years of the other party, except for one 4-year exception here when Ronald Reagan beat Jimmy Carter, but then it went back on track. And so there was a wave every 16 years. It would kind of reset and move on. It's unclear how long that will continue. Because if we look at the next pattern, we look at the presidents that were ranked, and we can see the highest ranked ones are George Washington, Abraham Lincoln, Franklin Roosevelt, times of war, times of uncertainty, and leadership was necessary. And the time between when they were elected is 72 years, roughly 72 years between these. And if you had 72 years to when Franklin Roosevelt was elected, you get 2005, which does not seem to continue this pattern. And so we also go back a few. We had pilgrims in Jamestown, kind of near this particular era. So there seems to be this 72-year cycle. This last one had a 16-year cycle in it, and then this, 5 of these cycles kind of placed in a modern era, kind of from 1600s onward. Before that was kind of the Renaissance and Reformation in the West, the High Middle Ages and Low Middle Ages, kind of 4 cycles within a 1500-year period, and roughly 375 years for each one of these, right? So again, we see the 375 years. So this is for the U.S. So we also take a look at others. So we summarize the western part in the middle. We take a look at 2 countries, very large size and dominating some things. So one is Russia. Had a very long history, a lot of invasion in there. And we can, early times it's a little bit uncertain what's going on, but the influence of the Vikings, the Byzantines, the Mongols, Muscovy, moving the Mongols, and then the Tsar period, and then recently communism. And you can see that almost every pair of these, so I have one blue, one orange, kind of matches up with these Western periods I have. If we look at the longer history of China, as not all the history is shown here, and some of the blue periods in here can kind of get kind of messy. There's a lot of dynasty and kingdoms, a lot of warring kind of going on, and typically the orange periods were longer in here until kind of this end. So again, we see the 375-year period here. Now, if you take a look at fox and rabbits type of model, where there's cycles in there is predator-prey model. And you put in there the birth rate and death rate, kind of like humans, you come out with a cycle of about 375 years, somewhere around there. So that might be one of the reasons for that. But we see kind of this period kind of reproduced in kind of these 3, at least a suggestion of how they might line up. So now that we looked at these historical national periods, we take a look back and take a look at civilization kind of in a longer time period than just the post-Roman and modern period. And so there are various analogies that are set up to kind of look at transitions from one phase to another. So one is to look at from hunter-gatherer to farming scenario. So on the left-hand side, we have kind of hunter-gatherer. They take a lot of room on this land. Then they grow in population, start to infiltrate each other's hunting area. Some of them feel the pressure, and they go to at least have some part of farming, and the amount of land that's required for farming is much less. So they reduce the pressure in that. But that means that their population growth increases, and so they start to push out on the hunter-gatherers, and so there's a phase transition, kind of as something crystallizing from a gas or a phase change. Also, we can see at a later time, kind of in the Roman and civilization period, there were a lot of different smaller entities in there, but there are economies of scale, and so if they join together, they have this smaller kind of surface area or boundary compared to the area. And so eventually, kind of one of the larger ones that can create economy of scale over which it can communicate, travel and communicate to control that area will eventually kind of win out. There's also one for the very particular period of Europe, which is kind of a surprise, a European miracle, in which it developed the technology, the Industrial Revolution. And there's always been a question why. Now, there's a lot of answers out there. But one kind of suggested this particular model, and this is kind of the prairie model. In a prairie, to maintain the prairie has to be burned every now and then by lightning, or in the U.S. in the Midwest, it was actually Native Americans that would burn just to maintain the fields and the prairie structure for the buffalo. Because what you want is to have some type of plant with deep roots and not having the weeds grow. And so the weeds might be something very quickly growing. Someone take advantage of something. But if you burn it all down, the things that really survive are the deep roots that continue to grow. And so you can have, some system kind of in a longer term outgrow something with a very quick turnover. And then finally, we look at, in terms of the Industrial Revolution, what happened is that many areas outside of Europe contributed many isolated innovations for working of metals, for the compass, for making paper, various processes. And what happened is that these isolated innovations, they didn't really add on to each other. No symbiotic relationship between them. But as they came to Europe at a particular time when it was kind of chaotic, all those innovations kind of fed on each other and drove that to a critical state. So we kind of think of it as a critical mass where enough innovations are being introduced to build on each other and create an environment, not only the innovations, but the funding and the combination of manufacturing and machining and testing some things that was needed. So we have this table kind of looking at that particular set. So we move on to the next part. We've now taken a look on from individual to technology to national scale to civilization, all the way back to hunter-gatherers. And now if we look at that, we can see that over time, for example, in the civilization, it took a long time for that first part to occur, a little bit shorter for the next part, and it kind of continued on up rather rapidly. So here we have about 6 different settings. So, for example, the civilization, it started about 5,000 years ago, about 1,600 years ago, that is in year 400, kind of the ancient civilization fell, was replaced with feudal structures. That lasted till about 500 years ago, 1500. Modern age came up, and then we have the contributions of innovations and the Industrial Revolution and information age, kind of leading to kind of a higher and higher complexity state with the new technologies feeding on each other. Now, this can also be applied to, besides civilization of 5,000 years, to humans, starting with 5 million years ago, kind of where the apes and the human line separated. It was not human at that stage, but it did split off from the evolution of chimpanzees and apes. And things kind of went quickly, kind of near the end. If this starts with 500,000 years ago, kind of with fire and language, and then things kind of sped up with agriculture kind of near the end of that phase. And then finally, another factor of 1,000 would be the Earth, starting about 5 billion years ago. And so it took a long time for life to evolve. Life was not there at the beginning, but it had conditions had to be set up for life to occur, for water and the earth to stabilize. And then there was a eukaryote revolution, so much more complex cell than 500,000 years ago, kind of the Cambrian revolution, and then more on plants, and then evolution of primates in their mammals and primates. So we can see this structure kind of repeating for these three major stages. Each one of these is kind of an ages, starting with the Earth, starting 5 billion years ago. There's kind of 6 stages, kind of an accelerating rate, followed by 5 million years of human evolution, followed by 5,000 years of civilization, leading to now. So this has been continually accelerating. So let's just ask what the next number in this sequence would be. So 5 billion to 5 million to 5,000 divided by another 1,000, it would be 5 years. So nothing's going to happen within 5 years to be comparable to any of these. So something has to not continue this pattern anymore. So we took away, so talked about the three major parts of agency-based evolution: life, humans, and civilization. And the one before that is just a factor of 3 between when Earth formed all the way back to the Big Bang. Factor 3, and that was just kind of a cooling phase, and where things were able to cool and kind of stick together to make bigger things like stars and planets, and also develop the elements needed. So just kind of look at this. We have the Big Bang about 15 billion years ago. I know it's 13.8, but it's rounded to 15, and then the Earth rounds to 5, and now you have the 555 and a factor of 3 to the Big Bang. It's easy to remember, and these things were, not formed in one day exactly at that particular time. And so if you compare this, what we have is that the Big Bang about 3 kilometers. We can see this in Central Park in New York City. 1 kilometer is kind of like the width of that, right? So the 3 kilometers would be the history of the universe, the age of the universe. The 1 kilometer would be equivalent to the age of the Earth, about 5 billion. Human line splits be about half the size of a person, about 1 meter. So you can see these time scales are getting really, really short, and then divide that by 1,000. And so it's about the thickness of a dime, about 1 millimeter. And so these times, 555, 1,000 apart, you can definitely, kind of view them in these distance scales, that they're quite a bit different. So if we put this into a larger perspective, just looking at the left of this, we had the Big Bang, and that cooled off by expanding. Then things started slow. There was life evolution on Earth. Then there was kind of human evolution, things speeding up, and then civilization. And so this is an overall logistic or learning curve. And we're kind of near that inflection point right now. Things are moving kind of fast. And as we saw, the pattern can't continue to go fast. So something has to happen. So one of the hypothesis is that it forms a big history logistic pattern, kind of in this hyperbolic kind of form, not a linear form. Obviously, we just looked at the scales of these times. Each one of these decreased by a factor of 1,000. So this cone just kind of represents that. And so the idea is that maybe it'll be reflective. There'll be 3 periods on the other side where things kind of begin to slow down as things become difficult to learn, discover new things, new technologies, and things will slow down again. We'll see. A lot of people predicted this would be in a few decades. Some people said already happened. We'll take a see. So one analogy then is at this inflection point, we made an analogy to the transition from some agricultural society to some advanced sustainable society. And in between, we use pretty much all the oil and fossil fuels in there, which is a finite amount and also causes environmental damage. So we make an analogy to this transition from agricultural society to advanced sustainable society as a rocket going into orbit. And so a rocket, again, also has finite amount of fuel. It launches very quickly, uses rather quickly a lot of the fuel, hopefully enough to get it up into the atmosphere with enough speed to get it into an orbit. Once it's in that orbit, it does not need any fuel to keep on going. It'll just go there every now and then a little bit, but it's in the orbit, so it's with the gravity effects in there. And so it's kind of self-sustaining again. Once that rocket gets into orbit, it's self-sustaining, just like with an advanced sustainable society, hopefully with wind and solar energy. We will be able to kind of propel ourselves, using this fossil fuel to do the science and technology development and hopefully figure out ways to better govern various things to get to an advanced sustainable society where we're no longer that dependent upon the fossil fuel that kind of got us there. And so we took a look at what's in this book. Just to review this, we looked at individual fractal patterns from 1 day to 70 years, kind of rest, and then we kind of extended that a little bit. Then we had technology waves of 70 to 100 years in there. Then we looked at national dynamics, so 3 phases of US. And then we compared it to Russia and China, and we saw some evidence for some 375-year cycle, something along that lines in there. So obviously China has shown that it can go through many dynasties and be at the same place and the same people. And then we looked at civilization stages by looking at analogies from 50 years to 5,000 years. Then we extended that civilization to human evolution, life evolution, looking at integrated evolution and the potential singularity that's nearby or already passed. And then we looked at a possible extension with that cone going from the Big Bang and then to the future where things might be slowing down. And we are now at the inflection, a very critical point where things are going the fastest. And usually when things are going the fastest, it's the most stressful. It's most likely to break. And so it's kind of an existential threat. And a lot of people saying that. Mark Rees, kind of the British royal astronomer, kind of said, we have about a 50-50 chance of making it through the 21st century. And others have really looked at that also. You can see a lot of global issues coming up in terms of economics being tied, in terms of technology, in nuclear or biological, things that can be good, things that can be bad. Pandemics that can go globally rather quickly, and cyber security, which is anybody at any place around the world can kind of attack or do something with IT, and so it's we need to find a way to kind of use the better parts of those for their benefits. So I went through this. I hope you enjoyed that. The book is available. Otherwise, you can always contact me. Just look me up on the internet. And please send me any questions or comments that you have. Thank you very much.